So, we've learned quite a bit about derivatives, how to find them, and their use and meaning in mathematics. In fact, though, they're actually used in many other sciences like economics, biology, and physics. Before we begin, a quick reminder that positive always denotes rightwards or upwards direction, and negative always denotes leftwards or downwards direction. This is why we show the gravitational constant as negative 10 meters per second squared. Let's examine a position function. We'll call it s of t. We know the units for position are meters, so when we take the derivative, we are finding the rate of change of meters, or meters per second. Sound familiar? These are the units for velocity. This means that the derivative of a position function is actually also a velocity function. Now, here's a man named Hercules who just wants to go the distance. He enters into a race and runs 50 miles to one end of the track and 50 miles back. When he is done, he claims that he has run 100 miles. But another man calls him out and tells him that he hasn't changed his position at all. How can the man say Herc went 0 miles if Herc thought he ran 100 miles? Distance is the total amount of units something travels in a specific amount of time, whereas displacement is the difference in units of measurement between the beginning and the end of a given time interval. Remember how Herc turned around and finished at the same point where he started? His total distance was 100 miles, but his displacement was 0 miles. At the point where he turned around, his velocity was 0 meters per second. How do we know this? When changing directions, his velocity changed from positive to negative, meaning it had to be 0 at the instant where he switched. Let's apply this to a problem. Say we have a position function called s of t and we want to find where the object turns around. Pause the video to solve this on your own. Since it will change direction where the velocity is 0 and s prime of t equals v of t, we need only find the derivative of s of t and then the zeros of v of t. The object should turn around at 1 second and 5 seconds. Now, what if the problem wants us to find the distance traveled between 0 seconds and 3 seconds? We begin by using the position function to find the starting position. In this case, s of 0 equals 10. Next, we find the position at the point on the interval where the velocity is 0. So in this problem, s of 1 equals 24. Make sure you do not skip this step. A common mistake is only finding the difference between the beginning and ending of a time interval, not accounting for points where the object changes direction. This would measure displacement, not distance. Finally, find the ending position. Here it is negative 8 meters. Once you have these measurements, find the distance traveled within each new interval. Don't forget to take the absolute value of these distances. We want to add them together to give us a positive final distance. Here, we add 14 meters and 32 meters together to give us a final distance of 46 meters traveled. Let's try something else. We know that velocity is the derivative of position, but what is the derivative of velocity? It's acceleration, the rate at which velocity changes. Its units are meters per second, or meters per second squared. The rate of change of meters is meters per second, and the derivative of position is velocity. The rate of change of meters per second is meters per second squared, meaning the derivative of velocity must be acceleration. Say Tigger is doing his calc homework on top of a building. He is very frustrated, so he throws the book off the roof. As the book gets closer to the ground, it will speed up. Why? The book's velocity will be negative because it is traveling down. The book's acceleration will also be negative since gravity is pulling it down. Since it is being pulled the same way it is already moving, the book will speed up. Now, say Tigger does really well on his calc test and decides to jump on top of his desk in joy. Tigger will slow down as he reaches his desk because his velocity is positive since he is traveling up, but his acceleration is negative since gravity is trying to bring him down. This means that he is slowing down because his negative acceleration is lowering his positive velocity. If acceleration and velocity have the same sign, an object will be speeding up. If acceleration and velocity have different signs, the object is slowing down. Say we have an object with velocity function 10 plus sine t. Its acceleration function would be cosine t. We are asked where the object is speeding up during 0 seconds to 3 pi seconds. This means that we want to know the intervals where velocity and acceleration have the same sign. First, find the zeros of each function on the interval so we know where they switch from positive to negative values. Label the number line as time with velocity and acceleration marked on either side. Now, put the zeros of each function on the number line. For both velocity and acceleration, mark whether the final value will be positive or negative for a number inside each of the new smaller intervals. Circle the intervals that have the same signs for both. Write these in interval notation and you have indicated where the object is speeding up. That's all for 3.7.